Have you ever looked up at the night sky and wondered why the moon is slowly drifting away from the Earth? It's a question that has intrigued scientists and stargazers alike for generations. The moon, our constant companion in the celestial sphere, is gradually moving away from our home planet. But why? Contrary to popular belief, the moon isn't just taking a leisurely stroll into the cosmos. Its drift is a result of complex interactions between the Earth and the moon, largely driven by two key elements: tidal friction and the conservation of momentum. Tidal friction, as the name suggests, is all about the tides. It's an energy exchange between the Earth's oceans and the moon's gravitational pull, causing a slow but steady increase in the moon's orbit. On the other hand, the conservation of momentum is a fundamental principle of physics that ensures the total momentum of the Earth-Moon system remains constant. So, the moon is not just lazily drifting away, it's a complex dance guided by the laws of physics. Now, you may be thinking, what exactly is tidal friction, and how does it contribute to the moon's gradual retreat? Well, let's dive right in. Tidal friction, in simple terms, is the energy dissipation that occurs due to the gravitational interaction between the Earth and the moon. This gravitational pull doesn't just keep the moon orbiting around our planet, it also causes the oceans on Earth to bulge out slightly in the direction of the moon. This bulge is what we commonly refer to as a tide. Now, as the Earth spins on its axis, these bulging tides don't align perfectly with the moon. Instead, they're slightly ahead due to the Earth's rotation. This causes a bit of a tug-of-war between the Earth and the moon. The Earth's rotation tries to drag the tides forward, while the moon's gravity tries to pull them back into alignment. Here's where tidal friction comes into play. This constant tug-of-war between Earth's rotation and the moon's gravity causes energy to be lost in the form of heat. This is the friction part of tidal friction. This loss of energy slows down Earth's rotation ever so slightly, but energy can't just disappear, it has to go somewhere. As the Earth's rotation slows, the lost energy is transferred to the moon, boosting its momentum and causing it to move slowly away from the Earth. It's a bit like a spinning figure skater who extends their arms to slow down their spin and move away from the center. The result of all this? The moon's orbit is gradually expanding, at a rate of about 1.5 inches per year. So, every year, the moon is roughly 1.5 inches further from the Earth than it was the year before. Thus, each wave that laps against our shores is a tiny reminder of the moon's inexorable retreat. Now that we understand why the moon is moving away, what does this mean for our lunar neighbor's future? Well, as the moon continues to drift away, it's slowly but surely causing Earth's rotation to slow down. This means our days are gradually getting longer, but don't worry, we're talking about a very slow process here. In about 50 billion years, a day on Earth could be as long as 1,000 present days. And what about the moon itself? Its orbital period will also increase, meaning it will take longer to complete a full orbit around our planet. It's quite the celestial slow dance, isn't it? But before you start planning for super long weekends, remember this process is happening over billions of years. So, while we won't be around to witness these changes, it's fascinating to consider the long-term effects of the moon's drift. So, though we won't see any drastic changes in our lifetimes, the moon's slow drift is a testament to the ever-changing nature of our universe. Let's take a moment to reflect on what we've learned about our drifting companion in the night sky. The moon, our celestial neighbor, is slowly moving away from us. The reason? It's a cosmic dance of sorts, dictated by tidal friction and the conservation of momentum. Like a tireless tango dancer, the moon's motion is influenced by the Earth's gravitational pull, causing tides that create friction and slow down our planet's rotation. This transfer of energy propels the moon further into its orbit, gradually increasing its distance from the Earth. And the future? Well, this lunar drift will continue, albeit at a snail's pace. This means longer days on Earth and the moon appearing slightly smaller in our night sky. So next time you gaze upon the moon, remember its slow dance away from us, a ballet choreographed by the fundamental laws of physics.